So my dear children, we are about to discuss the remaining questions related to our electricity lesson within this chapter. So let's head on to see what are the questions which are given. So you have to write the answers using given figures here right now. Now earlier there were several questions, we need to write down the correct answer. Now in these cases, by using the figures given, you have to write down the answers for the given questions. So the first question, what is the name given for P? This is P, and you can see that in P there are several cells. There are several cells within P. So if there are several cells, my dear children, you know that it's called as a battery. So this is a battery. Battery. Write the number of cells which used to make P. So count the number of plus or minus lines. 1, 2, 3. So there are 3 cells. What is the purpose served by R? So R is a permanent resistor. You can see the symbol, the zigzag line. So R is a permanent resistor. So we use permanent resistor in order to reduce the current flow in the circuit. So it is used to reduce the current flow in the circuit, or else to control the current flow in the circuit. To reduce the current flow in the circuit. To reduce the current flow in the circuit, we use the instrument called R, or the resistor. So resistor is used to reduce the current flow in the circuit, permanent resistor. So my dear children, P is the battery, the number of cells in the battery is 3, and R is used to reduce the current flow. So let's head on to the next question. Write the answers using given figures. So once again, the same figure is given, the questions 4, 5 and 6. What is the measurement obtained from A? So A is the ammeter. This A is the ammeter, right? As you can see, the A symbol refers the ammeter. So the measurement that we obtain from A is current in the circuit. So we obtain current in the circuit by using the ammeter. Reading received from A is 0.53 amperes. Write it in milliamperes. So you know that 1000 of milliampere is equal to 1 ampere. So in order to convert this ampere into milliampere, you just need to multiply this value by 1000. So 0.53 you multiply by 1000. You have to move 3 decimals, 1, 2 and 3. So our answer would be 530 milliamperes. 530 milliamperes. Then next one, how much is the current flowing through S? S is the bulb over here. Ammeter and S both are series connected. So each and every electrical charges which are flowing towards the R, towards the S, is also going to flow towards the ammeter as well. So if the ammeter reading is 530 milliamperes, 530 milliamperes of current should flow from S, and also 530 milliamperes of current should flow from R as well, right? So my dear children, answer for this question, as they are series connected, the same current is going to flow from each and every equipment. So our answer would be the same as above, 530 milliamperes. It is same as the above value because they are series connected to each other. So as they are series connected to each other, same amount of electrical charges or electric current is flowing towards the bulb, right? After that to the ammeter, right, which is going to show 530 milliamperes or 0.53 of amperes. Right then, next question. How much is the voltage of P? It is given that all are AAA sized cells. So if AAA sized cells are used, in a one cell there is 1.5 of volts. So there are 3 cells, 1, 2 and 3. So altogether 1.5 times 3, 4.5. To measure voltage of R, draw and show how the instrument is connected. So we are going to measure the voltage of R now. Voltage of R, my dear children. So to measure voltage, we use the voltmeter. So however, if you want to measure the voltage of R, then we need to directly plug in the voltmeter like this. And this terminal should be negative. This terminal should be positive. Right? It should directly be plugged into the two terminals of R. So this is how to measure the voltage of R, right? This is how to measure the voltage of R by using the voltmeter. Right then, in given figures, number of cells are increased from A to C. Now the second question is given under the third main question. So in each of these figures, you can see that number of cells are increased from A to C. So here only one cell, in the second one there are 2 cells, and in the third one there are 3 cells. What happens to voltage when moving from A to C? So it's quite obvious. From 1 to 2 to 3, if the cell count is getting increased, then so as the potential difference, as they are series connected to each other. So potential difference increase from A to C. So what happens to voltage when moving from A to C? What happens here is potential difference, or we can mention that thing as voltage. Both the things are same. So potential difference or the voltage increase from A to C. Which circuit shows the highest brightness in the bulb? So if you take the brightness of these bulbs, when increase in the voltage, you know that the current flow is also going to increase, thereby the brightness is going to increase. So select the circuit that has highest amount of potential difference, or highest number of cells. So the third one, C, is the one which is having highest number of cells with highest potential difference. The answer for this question would be C. What is the reason for above in second one? Because, you can write, because when increase in potential difference because when increase in potential difference current flowing also increases. Current flowing also increases. Therefore, high brightness is given. Therefore, high brightness is given. So, my dear children, this is the answer, because when increase in potential difference, current flowing also increases, therefore high brightness is given, right? So, C is the one which has the highest brightness, because when increase in potential difference, current flowing also increases, therefore we can observe high brightness, right? The next question. What happens to current flow when moving from A to C? Once again, you are asking about the current flow. So, in the earlier case, we wrote what happens with the current flow, right? When increasing the potential difference, current flow is also going to increase from when moving from A to C, right? So, we can write current increases when moving from A to C. So, when moving from A to C, current increases. If all bulbs were connected to C to have the same voltage, draw and show the circuit diagram. In order to have the same voltage, same potential difference, you have to connect that thing in a parallel connection, my dear children, right? Always remember, if it is given as same voltage, it should be a parallel connection. So, we'll draw the circuit symbol for this thing then. Always use straight lines when you are drawing circuit symbol. So, there are 3 cells in here. 1, 2, 3. So, let's connect these things each other. Then let's go for the circuit diagram. So, 3 lines together. Here we go then. 3 lines together. Then let's go for the bulbs. 1, 2, and 3. So, this is the circuit diagram to have the same voltage across each of the bulbs. So, here voltage is 4.5 volt. So, this one is also having 4.5 volts. This one is also having 4.5 volts. This one is also having 4.5 volts, as all of these things are connected in a parallel manner. right? 4.5, 4.5, 4.5, 4.5, 4.5. Right, parallel connection is going to give out same potential difference across all the equipments connected to the circuit. Right then, so we'll move on with the next question. Following figure shows a torch. Yes, now name all parts given in the figure. Number 1, so this is the most important part in the torch. That's the one which is going to emit light. It is the bulb, the torch bulb. Number 2, the second most important one, it helps to direct light as a parallel beam, right? So that one is referred as the reflector. So light reflector. Light reflector. Number 3, third one is really obvious, dry cells. Number 4, you can observe the spring. It's made up with a metal, so it should be a metal spring. Number 5, in number 5 is the switch. Then number 6, connectors. Can be copper or brass. Right, so these are the parts that we can identify in this simple torch. Number 1, which is over here, the bulb. Number 2, which is over here, the concave one, which is the light reflector. Number 3, dry cells. Number 4, it is the spring or metal spring, right? This is the metal spring. Number 5, over here, switch. Then number 6, connectors. It is made up with, most of the times, copper or with brass. So these are the main parts that we can observe within the torch. What is the use of 2? 2 means the reflector. So it helps to direct light into a parallel beam, right? You know that light is spreading here and there. I told you that when I was teaching this lesson part under the first chapter, we discussed this thing, right? Light is always spreading from a source. Light is giving out as spreaded rays. So when I'm going to use a concave shape, that light rays are going to hit on the reflector and travel parallel to each other. So spreaded rays are getting parallel to each other by this reflector, right? So it helps to convert spreaded rays into parallel rays. Spreaded rays are also referred as diverging rays. So reflector helps to convert diverging rays into a parallel rays. So we can write the answer. It helps to convert diverging light beams. It helps to convert diverging light beams into parallel beams. right? It helps to convert diverging light beams into parallel beams, right? So this is the answer for the reflector thing. Next one, what is the connection type of cells in the torch? Plus with the minus, then here plus, again here minus. So if plus minus are connected to each other, right, you know that it is a series connection. So the connection type of cells in the torch, series. Right? It is in a series connection. So the reflector, it helps to convert diverging light beams into parallel light beams. So the connection type in the cells is in a series connection, right? Okay, so let's move on with the next question. What are used as conductors in above torch? As the conductors, either we use brass or copper plates. Either we use brass or copper plates. Those are the ones which are used as connectors, conducting connectors. Right, so the final question, draw and show the circuit diagram for above. So for this circuit, now you have to draw and show the circuit diagram. So it's really simple, my dear children. In the earlier lesson part also, I mean like when we are discussing the lesson part, we drew out this thing, right? So now I'm going to once again draw and show how it is being connected. So it's really simple. Like this. Two dry cells, a switch. This is it. The switch, number 5 in here, the dry cells here. So you know that you have to interconnect this one, right? Dry cells. Then the bulb, torch bulb in here. And the connectors. Connectors. So it's a very simple circuit. Right. Following figure shows a diagram used for electrolysis. Now for electrolysis, this diagram is being used. So here two carbon rods or graphite rods are being used. Two dry cells are being provided to the circuit. You know that if carbon rods are being used, here we are doing the electrolysis process. Electrolysis means, for electrolysis process, in our syllabus, we use acidulated water, right? So let's name so in the first question, you have been asked to name 1 and 2. So we'll name 1 and 2. Number 1 is carbon rods. Number 2, acidulated water. Write an observation that will occur when passing electricity. So when passing electricity, what is the observation that we can see? So the observation is quite simple, my dear children. When electricity is passing through the solution, you can see that gas bubbles are getting emitted. So gas bubbles are evolved. Gas bubbles are given out gas bubbles are given out by the system, right? Gas bubbles are given out by the system. So this is the observation that we can take from the experiment, right? So let's see what is the other question given. If batteries are removed, what will be the observation? I'm going to remove the battery. So these are the carbon rods once again. Acidulated water. Right? So carbon rods and acidulated water. So here now in the third question they are asking, if batteries are removed, what will be the observation? Now if the batteries are going to be removed, there is no electric supply, there is no electric current. If there is no electric current, evolution of gas bubbles will going to stop as there is no electric supply. So if electricity is not given, the chemical change or the chemical reaction also will not occur. So we can write evolution of gases will stop. Evolution of gases will stop. So gases will not evolve here, right? Gases will not evolve. Next one, write the conclusion from the activity. So the conclusion is, when passing electricity, a chemical reaction has occurred within the system, right? When passing electricity through the solution, a chemical reaction has occurred within the system. That is our conclusion. How we can say that? Because of the evolution of gas bubbles. When passing electricity, a chemical reaction has occurred within the system. Right. So my dear children, this is our final conclusion. When passing electricity, chemical reaction has occurred within the system. That's why evolution of gas bubbles could be observed. Right. Write the energy conversion that occurs here. So the energy conversion is, we are providing electrical energy, and within the system that electrical energy is getting converted to chemical energy. So electrical energy to chemical energy is our energy conversion. That's how the energy is getting converted here. The electricity which is provided to the solution is getting converted into chemical energy. So electricity into chemical energy. Right? Electricity into chemical energy. This is the energy conversion that we can observe. Right. So the question number 5. Following figure shows a diagram used in electroplating. Now in the electroplating process, the diagram which is being used here is given. Name all the parts from 1 to 3. So number 1, it's quite obvious to see here by looking at this thing, we can say that it is a spoon. Number 2, so normally we are using or we are plating copper on this spoon. As they have never mentioned the type of a metal that is going to plated on the spoon, we can take this thing as copper. You can see that there is a special kind of a color as well, like a brownish yellow color. So definitely this should be copper. So we'll name it as copper. Copper plate. Copper plate. Then this is, the solution is copper sulfate. Copper sulfate solution. Copper sulfate solution. Right, so this is the copper plate, this is the spoon, and solution is copper sulfate. Right, okay. Then write 2 observations which occur here. Now we had write down 2 observations in here. If the plating process occurs in the proper manner, all of these 3 observations could be observed. Number 1, copper plate will dissolve. Copper plate will dissolve. Right, copper plate is going to dissolve within the solution and it's getting plated on the spoon. Then the second observation would be copper metal is plated on the spoon. Copper metal is plated on the spoon. Right, my dear children. So as the question is asking only about 2 observations, so I have written down only 2 observations. So the first observation is copper plate will dissolve. Right, copper plate is going to dissolve. And the second one is copper metal is going to be plated on the spoon. So these are the 2 main observations that we can see. When the time is going to pass by, the color of the copper sulfate solution is also going to reduce up to a certain level, right? It's because that the copper metal is getting plated on the spoon by dissolving this copper plate, and as well as within the solution also you can observe copper, as there is copper sulfate. So due to reduction of copper metal within the solution, the color, the blue color is going to reduce to a somewhat extent, not to a large extent. So color is also going to fade somewhat. Okay, right. If gold is plated on the spoon, what is the metal plate used? So if it is gold, then we have to use a gold plate. Gold plate. Right? Gold plate. Write a suitable solution which can be used to plate gold on the spoon. So it's really simple, my dear children. If it is gold, then we have to use gold sulfate. Gold sulfate. Right, the industrial uses of electroplating. Once again, you are asking about the industrial uses of electroplating. So we can write number 1, coat tin on coating on iron. Galvanizing. 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 Then number 3, plate gold, silver on iron. Right, so iron means it can be any type of an iron, a metal, a coin, a spoon, fork, anything. Okay, so these are the industrial uses of electroplating: coat tin on iron, galvanizing, plate gold, silver on iron. Right, so there is a figure given here. So following figure shows a diagram, a simple diagram. What is the connection method of dry cells in above circuit? So positives with positives, negatives with negatives. So this is a parallel connection. Parallel connection. How bulbs are connected each other? So actually there is a defect in this system. The earlier case, right, if there are 2 bulbs like this, we have to connect it not like, if like this is a parallel connection, or else like this. Right, in a series connection, this one with the outer terminal and the outer terminal is with the bottom one, like this. So here you can see that this wire is coming towards the bottom and it's going to the negative terminal. This wire coming to the bottom and from the plate is coming to the bottom once again. But this wire which is placed in here, it should not come to that place, it should come from this place to up. So there is a defect. So we'll continue with the questions, however, right? So there is a defect in the connection, right? So however, they have been tried to do a series connection, as this comes with this one and goes through with that one. So we'll write it as a series connection. Right? So they are trying to make a series connection, however, it's defective. Okay? So series connection. So the next question is given: what will happen to the brightness of the bulbs when cells are connected as above? Brightness in both the bulbs, the brightness would be same as it is parallel connected. Right, brightness is same. However, there is a defect. I told you that there is a defect, but however, he's been trying to connect it as a series connection. No, the 2 bulbs and the dry cells are connected in a parallel manner, so therefore the brightness of the bulbs would be the same. Next one, if you want to increase the brightness in bulbs, state the way of connection in cells. So if you want to increase brightness of the bulbs, let's imagine that this is not defective, I mean it's working, right? So if so, what should be done to the cells? So it's really simple. What do you have to do is, if you want to increase the brightness in bulbs, state the way of connection in cells. You have to change the parallel connection into a series connection. By that way, you can increase the voltage. Series connection. Right. If you want to increase the brightness in bulbs, state the way. So way is series connection. Right? Series connection. So draw and show the circuit diagram for the above figure. See, by recorrecting the error. So we have to recorrect the error and we have to draw the circuit diagram. So we'll keep the system like this in the same way and we'll recorrect the system first of all. So here this one should go like this. This line over here, this line over here should erase. Right. Right, my dear children. Now we have corrected the error in the diagram. Now let's draw out the circuit diagram for this one. So here you can observe a resistor and two bulbs connected each other in a series connection, and there are three cells. So let's draw the circuit diagram then. I have to use straight lines. Three cells. Then after, right? So we'll draw out two bulbs, 1, 2 series connection with a resistor. There's a resistor. So we have to draw out the circuit diagram for a resistor. So as the resistor is given like that, we'll draw it in the same way like the given diagram. Then resistor. After that, the three dry cells. 1, 2 and 3. All the negatives together, all the positives together. So this is the circuit diagram for the given diagram here, right? All the positives together and all negatives together, right? So here you can see that the resistor is connected to the positive terminal. So we'll draw it like that way, my dear children. So here we'll erase this part and we'll draw the resistor over here. Here we go, the resistor and the bulb. Right, now it's okay. As per to the figure, it's identical to the figure. These are the plus terminals and these are the minus terminals. Right, so this is the circuit diagram and this is the recorrected error. Right. Draw and show the circuit diagrams. So you have to draw the circuit diagrams for the given things. 3 bulbs in series connection with a resistor and a switch. 4 cells are connected series to provide electricity. So we'll draw it. There are 4 cells. 4 cells. 1, 2, 3 and 4. 4 cells. Let's interconnect. Then three bulbs in series connection with a resistor and a switch. So we have to draw 3 bulbs in series connection. 3 bulbs in series connection. So as there is a switch, I am going to draw the switch first. Switch. Then the 3 bulbs. Okay. So we'll connect this thing. Now 1, 2, 3 and the resistor. So 3 bulbs in series connection 1, 2 and 3 with a resistor and a switch. 4 cells are connected series to provide electricity. Right. Next one. 2 bulbs in parallel connection. 4 cells are connected series to provide electricity. 2 switches to turn off 2 bulbs when needed. A main switch to turn off both bulbs together. Right. Two bulbs. You have to use 2 bulbs in here and 2 switches to turn off the 2 bulbs when needed. Right? So the switches here we go. The 2 switches, then the 2 bulbs which are parallel connected to each other, and my dear children, there should be a main switch. Right? There should be a main switch to turn on and off both the bulbs together, and 4 cells connected series. There should be 4 cells. 4 cells. 1, 2, 3, 4. Let's interconnect. right? Then finally, let's complete the circuit. Right, so this is our circuit then. 4 cells, 1, 2, 3, 4, connected in a series, 2 bulbs in parallel connection, 2 switches to turn off the bulbs when needed, and main switch to turn off both the bulbs together. This is the main switch. These are the 2 other switches to turn off the bulbs. Right, so the next one. Resistor with 3 series connected dry cells and a switch, voltmeter and an ammeter to measure the voltage and current of the resistor. Simple. 3 series connected dry cells, 1, 2, 3. A switch, and a voltmeter and to measure the voltage, we have to connect a voltmeter. Right, now let's fill out the blanks. First of all, a switch. Here we go, the switch. Then the ammeter, right? So this one should be negative, this one should be positive. After that, the resistor. Then to measure the voltage, the voltmeter. Once again, this terminal should be positive and this should be negative. So simple. Resistor. So I have connected the 2 terminals directly to the resistor to measure the voltage. So this is the plus terminal which runs to the plus terminal, the minus terminal that runs to the minus terminal. Right then, this is the voltmeter to measure the voltage, ammeter to measure the current in the circuit. Right, and there is a switch. Next one, number 4. 3 parallel connected 3 volt dry cells, 3 LEDs parallel connected with switches each to turn off when needed. Voltmeter to measure the voltage in the circuit, main switch to turn off all bulbs, ammeter to measure entire current flowing through the circuit. Right. 3 parallel connected 3 volt dry cells. So I'll take the slide somewhat up, will be needing somewhat more space here. 3 parallel connected 3 volt dry cells. 1, 2, 3. Parallel connection. Okay. 3 LEDs parallel connected with switches each to turn off when needed. We'll draw it then. LEDs, right? 3 LEDs, all are parallel connected to each other. Okay, remember to put that sign of the LEDs. Okay, then switches to turn off all bulbs. Switches to turn off all bulbs. So we have to put a switch to turn off all the bulbs together. Now in order to do that, right, we have to place a switch in this kind of a place. We'll intersect this one. This is the main switch. So let's insert the switches now. The main switch, these are the secondary switches. Secondary switches. Here we go. This switch need to be turned on first of all in order to flow electricity from these three parallel connected risers. Then after that, by turning on this one only, you can light up the first bulb. If you turn on this one, then you can turn on the second bulb, this one, third one. Always remember, this is the negative terminal. These are the positive terminals. Right? Positives, negatives. So 3 parallel connected 3 volt risers, 3 LEDs parallel connected with switches each to turn off when needed, voltmeter to measure the voltage in the circuit. Now we need to connect a voltmeter. So once again, we have to use a voltmeter. So you know that voltmeter should be connected in a parallel connection, right? So voltmeter, then ammeter to measure the entire current flowing through the circuit. Ammeter to measure the entire current. So if an ammeter is getting used to measure the entire current, right, then we have to use it over here. At this place we can use it, right, like in the switch, the ammeter. Here we go then. So you know that ammeter should be directly plugged into the circuit as it is in a series connection, right? Some kind of a difficult one, however we have managed to draw it out. So 3 dry cells parallel connected, 3 LEDs parallel connected ammeter to measure the current passing through the entire circuit, voltmeter to measure the voltage given. And there is a switch, a main switch to disconnect all the connections, and switches each to light up each bulb when we need. Right. So let's head on with the next question. 3 red LED series connected, 3 blue LEDs series connected. Red and blue LED lines are parallel connected each other. Switches separately turn on and off blue and red circuit lines. 4 cells series connected, main switch to turn off all LEDs at once. It's like a lighting system, right? So I'll use red color to show the red color LEDs. Red color LEDs. So there are 3 red LEDs. 1, 2, 3 red LEDs series connected, and 3 blue LEDs series connected. Red and blue lines are LED lines are parallel connected parallel connected each other. Switches separately to turn on and off blue and red circuit lines. Let's draw out the blue color line as well. Right. Now let's interconnect these things. By using connecting wires, let's interconnect. So before that we have to put a switch. Here we go. Our 2 circuit lines are now completed. So we have to draw the arrowheads. As these things are LEDs, it's important to draw and show those arrowheads. So let's draw and show the arrowheads, my dear children. Right. LEDs. Then let's interconnect these things by using connecting wires. So I'm going to use black color ones as my connecting wires. Okay, now 3 red LED series connected, done. 3 blue LED series connected, done. Then red and blue LEDs are parallel connected, done. Switches separately turn on and off red and blue, on and off blue and red circuit lines, done. Switches separately. 4 cells series connected, main switch to turn off all LEDs at once. Now we need to provide only the cells. main switch. Right. Negative terminal with the negative, longer positive with the positive. So when I'm going to turn on this switch, all LEDs are going to light up, but however we have to turn on and off blue and red as per to our need. So this is the circuit diagram for this particular description. Right, so these are the circuit diagrams, my dear children. Name the instrument used in given instances. Illumination. So instances, several instances given. Illumination, to reduce the current flow in a circuit to a fixed permanent value, to vary the current as per to a desired value in a circuit, to change the volume in a radio, to cut off electricity supply when needed, to vary the current in a circuit as per to intensity of light. Right, so you have to write down the instrument used in each of these instances. So we'll write down, my dear children, the answers. So first is given for illumination. For illumination, we use bulbs or LEDs, right? Very simple. Bulbs or LEDs. To reduce the current flow in a circuit to a fixed permanent value, that means we can't vary it. So in that case, we use a permanent resistor. Permanent resistor. To vary the current as per to a desired value in a circuit. As per to a desired value. As per to a desired value means whatever the value that we want. So you have to use a rheostat. To change the volume in a radio, really simple, my dear children. To change the volume, we use the volume controller. Volume controller. To cut off electricity supply when needed. Really simple once again. To cut off the electric supply, we use a switch, right? A switch. To vary the current in a circuit as per to intensity of light. As per to intensity of light, vary the current in a circuit. Once again, it's really simple, my dear children. What you have to do, what you have to use is an LDR. So use LDR. According to intensity of light, light-dependent resistor is going to help to change the current flow. So LDR is the answer. Right then, so we have answered all the questions given under the extra exercises part. So I hope that you have got a sound knowledge regarding to the electricity lesson. So my dear children, I hope to meet you with our next lesson in our grade 8 syllabus. So till then, it's time to say goodbye.